Good everyone, welcome back again to my YouTube channel where I teach chemistry, okay, for passion. Alright, today we are on a series of gas laws, and so far we have looked at Boyle's law and we have also looked at charge laws. Today we are going to the third aspect of gas laws, which says general gas equation. General gas equation. General gas equation. A general gas equation is the combination of both Boyle's law and Charles law. Right? You get it? But what is our Boyle's law? Boyle's law says that the volume of a given mass of gas, okay, is inversely proportional to what? To pressure, provided what T is constant. Remember, what Charles law, okay, states the volume of a given mass is directly proportional to temperature, provided that P is what? Constant. So let's combine the two laws together and let's see how this works. Okay, this is inversely proportional. This is what directly proportional. Combining, they have two things in common. That's what? That's volume. So let's look at volume. Okay, equals to our proportionality constant. Don't forget, it was T over what? T over P. Did you get it? T over P. So let's make our K the subject of formula. In doing that, I'm going to cross multiply. Your K equals to what? Your PV over T. Alright. Now, if we vary this as usual, as we vary our Boyle's law and Charles law, we are going to have our formula to be P1 V1 over T1 equals to P2 V2 over T2. Did you get it? This is our general gas equation. That's what we're going to be using for all our calculation on this particular topic. Now, what is the meaning of P1? That's initial pressure. The meaning of V1, that's what? Initial volume. And T1, initial temperature at Kelvin. Okay, I remember I told us on that Charles law that temperature from Celsius must be converted to what? To Kelvin. Now, P2 is final pressure, while V2 is final volume, and T2 is what? Is final temperature. Now, let's look at something. At STP, a reminder, your pressure can be, if it's ATM, it's 1 ATM. That's the standard. STP means standard temperature and pressure. Okay? Now, at STP, let's look at it. P equals to what? 1 ATM. P can be 760 mm Ag if the unit is mmAg. And P can also be 1.01 exponential 5 nanometer per square if it's in this unit. These are standard that we must know. And for our temperature, must be in Kelvin, which is 273 Kelvin. And for our volume, okay, at STP, our volume is in DMQ is 22.4 DMQ. But our volume, if it's in CMQ, it's going to be 22400 CMQ. Did you get that? Did you get that? Okay, I think you need to know how to solve relative problems that I come on our way under this particular topic. So let's be diving into one or two examples. Example one. Example one states that 1050 CMQ of helium, alright, of helium gas was produced at minus 33 degrees C and 770 mmAg. What volume would the gas occupy at 23 degrees C and 750 Hg. Look at the question on the board now. Everybody check the question on the screen quickly. Now we are looking for volume now. We have our initial volume to be what? To be 1050 cm3. We have our initial temperature to be minus 33 degrees C. And we have our initial pressure to be what? To be 77 mmHg. Our pressure is reduced to 750 and your temperature is 23 degrees C. So we are looking for volume 2. Okay. How do we attack this situation? Of course, yesterday I told us that anytime we are giving question that has to do with temperature in Celsius, it must be converted. It must be changed to what? To Kelvin. Let's really do that. So we can add 273. We can also add 273 of 240 Kelvin. We are going to have 296 Kelvin. So now our formula is ready. Can we use our formula quickly? I hope you are following. Please make sure you follow me to the end. So let's use our formula. P1 V1 over T1 equals to P2 V2 over T2. Students, please take note. Anytime you are solving any questions, make sure you have the parameters ready. It's very important so that you know exactly what you are doing. So we have our V1, P1 to be what? 76770 multiplied by 1050 divided by 240 equals to my P2 750 multiplied by what? By volume, that's what I'm looking for, divided by 296K. Okay. Now in doing this, you're going to cross multiply. In cross multiply, you're going to have V2 equals to 770 times 1050 times 296 divided by 240 multiplied by 750. Okay. So let's take your calculator. Okay. That's our final answer. Did you get it? Did you get it? I hope so. So let's move on to example 2. Without wasting time, let's go to example 2. Just look at the screen. Look at the screen. Quickly, look at the screen. 200 cm3 of a gas at 25 degrees C. Exact pressure of 700 mmHg. Calculate its pressure. Calculate its pressure if its volume increases to 350 cm3 and temperature is what? Temperature is 75 degrees. At 75 degrees. Let's quickly do that together. You have our P1 here. You can see the analysis on the board. Look at the screen. Our initial volume is 200. Our initial temperature is 25 degrees C. Initial pressure 700 mmHg. Final pressure, that's what we're looking for. Final volume 350. The volume increase. The temperature also increased to 75. Alright, now we are going to use this formula. P1 V1 over T1 equals to P2 V2 over T2. Alright, but before then you have to convert your temperature to Kelvin. So plus 273 and plus 273. I hope you are doing that already. So I'll give us 298. And so I'll give you 348. Pick up calculator, let's confirm 348 Kelvin. Did you get that? Did you get that? Yes. So let's really use our formula by substituting respectively the values that we have. So our P1 now will be what? Will be 700 multiplied by 200 over 298. Okay, it give us our P2, that's what we are looking for. Our V2 is 350, remember it increases, divided by T2, which is on 348 Kelvin. No, let's cross multiply to get our final answer in mmHg. Alright, we have 700 multiplied by 200 multiplied by 348 Kelvin divided by 298 multiplied by 350. Can I give you a seconds to press your calculator and get the answer for this? 46711 mmHg. Did you get it? Correct. Clap for yourself. Clap for yourself. You are falling. Good. Now let's go to example 3. Example 3. Hope you are following example 3. Alright. Can we manage this place? Example 3. Okay. Example 3. Example 3 says a certain volume of a gas at 298 Kelvin is heated such that its volume and pressure are now 4 times their original values. What is the new temperature? T1, V1, P1, and we need our V2 and P2. The question said the value was heated 4 times the original value. You can decide to pick. I see my initial is 1, 4. This one is 1, this one is also what? 4. Or decide to pick 2, then you just look at the number 4 times. Okay, we have our parameters. We are looking for temperature, of course, now in Kelvin. So let's use our P1, V1, T1 equals to P2, V2, T2. Our P1 is 1. Multiplied by our V1 is also 1, right? Divided by 298 equals to our P2 4 and our V2 4 divided by T2. That's what we are looking for. Let's multiply it quickly. We have our T2 equals to 298 multiplied by 4 multiplied by 4 divided by 1 divided by 1 multiplied by 1. Give you another seconds to press your calculator and get me the answer. 768. Okay, did you get the same thing? Did you get the same thing? Good. That means you are following. Let's go to example 4. Example number 4. Example 4, please. Let's look at example 4. Look at the screen. A given mass of gas occupied 500 cm3 at 30 degrees C and 6.5 times 10 to the power 4 nanometer per square. Calculate the volume of the gas at STP. Of course, at STP, your temperature will be 273 Kelvin and your nanometer per square is going to be 1.01 exponential 5 nanometer per square. Now let's look at it. Look at the parameters here. Come closer, look at the parameter. Come closer, look at the parameter. Can you see the parameters? We're going to go use our formula P1, B1 over T1 equals to P2, V2 over T2. Of course, I'm going to convert this one plus 273. That's giving us 303K. And this one is already converted. Did you get that? Did you get that? Okay, quickly, let's calculate it. Now, P1 is 6.5 times 10 to the power 4, and my V1 is 500 over T1, which is 303, equals to P2, which is 1.01 times 10 to the power 5 rather, divided by T2 is 273 multiplied by my V2. That's what I'm looking for. My V2. Okay. Alright, let's make V2 the solid formula. Student, take note. As a chemistry student, you must be sound in mathematics. Alright, so let's just cross multiply. We will have 6.5 times 10 raised to the power 4 multiplied by 500 multiplied by 273, okay, divided by 303 multiplied by 1.01 times 10 raised to the power 5. That's my V2. So my final answer now, let me give you a minute. 289.9 to cm3. Please check out and confirm the value of V2. Example 5. Example 5. This is a UTM question, okay? UTM question number 5. The pressure, just look at the screen, the pressure of 100 cm3 of oxygen at 35 degrees C is 750. Alright? What will be its volume? What will be its volume of the gas if the pressure is reduced to 100 mmHg without changing the temperature? Okay, let's calculate this. Let's change this one to Kelvin 273. That's 308 Kelvin. The same temperature did not change. 273 as 308 Kelvin. Alright. Using our formula P1, V1, T1 is equals to P2, V2, T2. Our P1 is 750 and our V1 is 100. Divide by our T1, 308 equals to P2, 100 times V2. That's what we're looking for. And our T2 is also 308. So my V2 now, let's multiply. You have 750 times 100 times 308 divided by 308 times 100. This one cancels this one, this one cancels this one. My final answer is what was 750 mmHg. I hope you have enjoyed the class. There are a lot of other questions on this topic. Okay, but I'll see you in my next video. ID gas equation. Signing out. Thank you.